Hello friends, this video on sound part 1 is brought to you by examfear.com. No more fear from exam. Topics to be covered in this lesson are introduction, production of sound, propagation of sound, sound waves are longitudinal, characteristics of sound waves, speed of sound, reflection of sound, range of hearing, and human ear structure and function, along with applications of ultrasound. So what do you think are we going to study in this lesson on sound? So whenever I say sound, there are so many things that come to our mind. I mean, I really don't need to introduce this lesson. You know what do I mean when I say sound. There are so many different kinds of sounds which we actually hear, right? In fact, right now I'm speaking, that makes sense because you're able to hear it. Because of the sound which is being produced by me is being heard by you. That's how it makes sense, right? Similarly, we think of any sound. We think of the music which we hear. It might be a music in a Hindi movie. It can be the music produced by a musical instrument like a flute or a guitar, or the band party which goes generally during the Indian weddings, right? The barat which goes during Indian weddings, or the sweet voice of the cuckoo, or if you think of the bell, whether it's the temple bell or your school bell. So the ringing of the bell is again a kind of sound which we hear. When somebody is talking, like the way I am talking right now, and you are able to hear, so that is again a sound. You can try this small example. You stretch a rubber band and leave it. You get a sound, a slight sound, right? So if you think of sound, there are so many different varieties of sounds which we actually come across in our day-to-day life, right? So in this lesson, we are going to talk about sound. We're going to see how is sound actually produced, from where does the sound is produced, how the sound reaches from one person to another. For example, right now I'm speaking and you're able to hear. So how is the sound getting transmitted? So we'll talk about the production of sound, we will talk about the propagation of sound, we will also talk about the various properties which actually characterizes a sound, right? So this lesson is all about sound, okay? So with this, let us start from the very basic, and the basic question is, what produces sound? So how is the sound actually produced? So did you notice something in the examples which I cited in the previous slide? Let us look at those examples once again. Let us look at this guitar. How do you produce a sound with the help of a guitar? Let us suppose if I keep a guitar on the table, will it start producing sound? Will I be able to hear the nice music from the guitar? No. Unless and until you move the strings of the guitar, you will not hear any sound, right? So in a guitar, the sound is produced by the vibration of the strings. So these guitar strings which you have, a guitarist will do what? He will actually move these strings, right? Okay. Next, if you look at the bell, how does this bell produce sound? If you would have gone to a temple, you would have seen that this thing which you have in the bell, this one, so when you move it, what happens? It starts vibrating, it starts moving, and because of its movement, the sound is produced. Similarly, when you take the example of somebody speaking, when somebody speaks, how is the sound produced? In the vocal cords, I mean, if you look inside the human structure, in our vocal cords, the vocal cords actually vibrates, and because of that vibration, the sound is produced. If you do not vibrate that, no sound will be produced. Similarly, the best example for you to understand, you take a rubber band in your hand, it will not make any sound, but when you stretch it and then leave it, it makes a sound. That is again because of the vibration. So the bottom line is that sound is produced by vibration of object. So I hope all of you are clear with what is vibration, right? Vibration, the term vibration literally it means something which is shaking. So vibration is nothing but a rapid to and fro motion of an object. So that means an object is swinging between two positions, right, left, right, left, right, left. So when that to and fro motion takes place very rapidly, we say that the object is vibrating. So sound is always produced by vibration of objects. So now if you look at any of the examples which I gave in the previous slide, everywhere you will see that there is a vibration which is responsible for the production of sound. Right? We are good to go? Okay. So with this, let us now talk about the propagation of sound. That means how does sound travel? Okay, so we understood that when some object vibrates, sound is produced. Fair enough. So now the sound is produced in the guitar, but how is that sound reaching from the guitar to the listener's ear? So how is that sound traveling from the guitar to your ear? That is the next question. So let us try to understand how sound propagates. So sound propagates through a medium. So again you have a new term here. Medium. So what is this medium now through which sound will travel? So let us look at some of the examples. Before that, let us try to understand what is a medium. An object through which sound is transmitted. So that means in order that sound is able to reach from one point to another, you need some object which will carry the sound. So that object is nothing but medium. Let us look at this example. Let's suppose if there are two boys, this boy is speaking something. So the sound is traveling to this guy. So how is the sound traveling? Through the medium. What is the medium here? Here there is a rod kind of a structure, but inside the rod, what do you have to carry the sound? It is nothing but air, right? Even if you don't have this tunnel-like structure, even if this guy speaks and this guy hears, it is like the sound is being traveled through the air. So air is a medium by default. Correct? So how actually the propagation of sound takes place through this medium? Now this medium can be a solid or a liquid or a gas. So that means so sound can even travel through a liquid, sound can even travel through gas, and it can travel through some solid object as well, right? So it can be anything. Now the question is, how is sound getting propagated through an object? So this is the example when we talk, even in that case, air acts as a default medium. So air is not the only medium through which sound can travel. There are many other medium. For example, you can think of a solid object. For example, let us suppose you are in one room and your friend is in the other room. So when you speak from this room, if you speak little loudly, your friend is able to hear. That's because sound is able to travel through the solid medium, that is through the wall. So the wall is not acting as a barrier. Your friend is also able to hear you. So that means that solid substance is acting as a medium. So there are many different mediums that can be solid, liquid or gas, but air is by default a medium which helps in propagation of sound. But the important point here is that sound needs a medium to propagate. If there is no medium, sound will not be able to propagate. So we will talk about that part also a little later. So right now let us try to see how actually the propagation of sound takes place, how actually the sound is transmitted from one point to another. So here we have taken the example of a speaker. Let us say this is the source of sound. So this object is producing sound and this is the ear of the listener. So this is the person who is listening. So how is sound traveling from this point to this point? That is the question. So what happens in this case is, sound is produced here because of some vibration, right? There will be some vibration taking place inside. So as a result, there is some vibration in this object. As a result, particles of this medium which are in direct contact with the object gets displaced from their equilibrium position. Let us suppose, let me draw a rough diagram. Let us say this is my object, that is the source, right? So this object vibrates. So vibrates means it will move like this, it will come back like this, again it will move like this, it will come back like this. So this kind of to and fro motion is known as vibration. So this object vibrates. So when this object comes this side, let us suppose there is a particle 1. So this particle is nothing but these are the particles of the medium. So we assume that if the medium is air, so air will have so many particles in it, right? So let us suppose there is one particle in the air which is in the neighborhood of this object. So this particle will also get pushed in this direction, right? So now, so the particle 1 gets displaced from its equilibrium position. So now this particle will exert some force on another particle. Let us suppose there is some particle 2 here. So this particle 1 will exert some force F on this particle, right? Now after exerting this force F on particle 2, this particle 1 will come back to rest, right? So 1 went this side, it came back, correct? When 1 went this side, it pushed 2. So 2 again went this side. So now what will 2 do? 2 will exert some force F on particle 3. So it will exert some force on particle 3 and again it will come back. So as a result, this particle 3 will start moving in this way. So what we are seeing actually, what is happening? So every particle of the medium is actually vibrating. They are actually moving on its own position. So that means every time this object is also vibrating. So it will keep coming this side, then going back this side, again coming this side, going by this side. So every time this object is coming in the right direction, it is pushing 1 to right, 1 will push 2 to right, 2 will push 3 to right. So as a result, every object is vibrating or it is oscillating in its own position. But as a result, this vibration or this disturbance, this is a kind of disturbance, right? Because of the vibration of the source, there is a disturbance which will keep on moving from particle 1 to particle 2 to particle 3, because this disturbance is getting transmitted, and this disturbance is nothing but sound. So if you look at this diagram very carefully, you will see that just observe any one particle, you will be able to, when you look at this picture, what do you see? You feel that you can see very clearly that the disturbance is moving along this direction, right? So this disturbance which you see, I mean, you do not see the particles individually, you just look at this picture as a whole. What do you see? You see, it looks as if everything is moving towards the right side. So that is the disturbance which is getting transmitted. This disturbance which I told. You see, this object pushed 1, 1 pushed 2, 2 pushed 3, 3 pushed 4. So the disturbance is actually moving towards the right direction. That is known as propagation of sound. But when you look at each particle of the medium, just observe any one particle. For example, let me take this particle. There is one particle here. If you look at only this particle, do not see anything else. What do you see? How is the particle moving? The particle is not going anywhere. It is just oscillating about its mean position. Once it is going right, once it is going left. Once it is going right, once it is going left. Similarly, you look at any other particle. Let me consider this particle. Now, if you look at this particle is again oscillating about the red dot. Right? So, every particle of the medium, none of the particles are actually moving from one point to another. So the particles of the medium are actually helping the sound. Sound is nothing but the disturbance. It is actually helping to transmit the disturbance through the neighboring particles. But the particles of the medium do not move as such. Right? So what is the conclusion? The first conclusion is that particles of the medium do not move forward themselves, even though it appears that the disturbance moves forward, but the particles of the medium do not move forward. Right? Second is disturbance is carried forward through the particles of the medium. So here the disturbance is carried forward. So these are two different things. One thing is the particles of the medium, what are they doing? They are just oscillating. They are just vibrating about their mean positions. But as a whole, if you look at it, the entire disturbance is getting transmitted. And this disturbance is nothing but sound. Right? So what do we see? So this disturbance is the sound, and that sound is again a wave. So this shows that it is nothing but a wave. Sound, when I talk of sound, sound is nothing but a sound wave actually. So sound is a form of wave. So what is wave? I'm sure all of you know what is wave. Wave is nothing but it is a disturbance in a medium. See, if you do not have this source of sound, there will be no disturbance in the medium. The particles will not oscillate at all. So if the particles do not oscillate, there will be no sound. But wave is something, wave is a disturbance which is created in a medium by some external source. So here the external source is the source of sound, that is the speaker. Right? So it was a source which created a disturbance in the entire medium. So this disturbance is known as a wave, and here the kind of wave which we have is a sound wave. So now you understood how sound wave propagates. Sound wave propagates through the particles of the medium, but the particles of the medium do not move themselves. They actually oscillate about their mean positions, and as a result the disturbance or the sound is carried forward through the particles of the medium. Let us now talk about compressions and rarefactions of a sound wave. Now let us see what are compressions and rarefactions. So let us take the same example. What is happening here? The sound is getting transmitted from the source to the listener, right? So what are compressions? Compressions and rarefactions are the two terms which are used to characterize a sound wave. So what are compressions? Compression means something which is compressed. The term itself means something which is compressed, something which is very congested, right? So here if you see, there are certain regions. Now when the object moves, now think of what we discussed in the previous slide. How is this movement happening? When this object vibrates, what happens? Let us suppose when it moves forwards, it pushes the neighboring particles. Right? So when it pushes the neighboring particles, it is actually compressing the region in the front. That means, let us understand it in this way. Let us suppose if this is my object, if this is my source. So when it vibrates and it moves in this direction, what is happening? Let us suppose if these are the particles of the medium. So this will move this side, so it will actually compress the particles here. So the particles will come close by, right? Again, when this object comes back, when it comes backwards, what happens? These particles are wide away from each other. They are not compressed now. So when they are compressed, that means when this object moves forward, in that case, the neighboring region becomes a region of high pressure, or we can see that the density of the particles is high. If you look at it, here you can see that when this particle moves in this direction, what happens? A high compression region exists here. That means a high pressure region. So the region where the density of particles is more, the region where the congestion is more, it is more congested, right? So if you look at this figure as a whole, you will see that there is one region where the particles are more congested. There is one region where particles are wide away from each other. So the regions of high pressure or high density is known as compression, and the region of low pressure and low density is known as rarefaction. So these are the two very important terms, compression and rarefaction. So compressions happen when the object vibrates in the forward direction, because when it vibrates in the forward direction, it exerts a force in the neighboring particle. As a result, the neighboring particle comes closer, so the density of particles increases. So that time it has more pressure, so it is high pressure, high density, that is called compression. Similarly, when the object moves backward, so then there is less pressure on the neighboring particle. As a result, the neighboring particles can move away from each other, so a region of low pressure is created, and that is known as rarefaction. So in this case, we can say that this is compression. I mean, if you do not take an animated figure of this, so you can say that this is compression and this is rarefaction. Again, this is compression, again this is rarefaction. So you have alternative compression and rarefactions. So in rarefaction, you see the particles are quite away from each other, but in compression, they are very close to each other. So from the term compression, you can remember compression means something which is compressed. So when you compress something, all the particles will come very close by. So the density of the particles will be more. So the pressure will also be more, right? So that is how you can remember what is compression and what is rarefaction. Now, as I mentioned before also, that we spoke about that sound needs a medium to travel or to propagate. Now, can sound travel without a medium? Let us suppose if I do not have a medium, if there is no air, no water, no solid object, nothing. So do you think that sound can travel without a medium? Can sound travel through a vacuum? Vacuum means an empty region where there is nothing, not even air. So that is known as vacuum. The sound needs a medium to propagate. It cannot propagate through vacuum. So that means presence of a medium is a must for sound wave. So how was this proved? To prove this, there was an experiment which was performed, which is popularly known as the bell jar experiment. So what was this bell jar experiment? In this, what was done was that an electric bell. So you can see here it is an electric bell. If you press here, sound should come, right? So this electric bell was placed inside an airtight glass jar. So this is the jar, and inside the jar we had this electric bell. That is why it is known as bell jar experiment. Okay, so this was airtight. So air cannot enter into this glass, right? And then this was connected to this jar was connected to a vacuum pump. So that means it is a pump which if you switch it on, so vacuum will start entering inside. Vacuum will start entering inside means air will keep going out. So gradually after some time it will be all vacuum. There will be no air at all. Correct? Now what was seen that as vacuum was pumped in, air was pumped out gradually. That is obvious. What was observed was that the sound of this bell became dimmer. That means as more and more vacuum pumped in, the sound of the bell started becoming dimmer, and at a certain point of time when there was no air inside and it was all vacuum, the sound of the bell was not at all heard. So what did that prove? That proved that sound cannot travel through vacuum. So it actually needs a medium, and that makes sense also, because we saw that how sound propagates. It actually propagates because of the vibration of the particles of the medium. So if you do not have a medium, that means you do not have the particles of the medium. If you do not have the particles of the medium, then how will the sound will get propagated? There is nothing to vibrate. Correct? Because normally how it is getting propagated? It is getting propagated because of the vibration of the particles of the medium. So the particles are vibrating, that is how they are making the neighboring particles also vibrate. So if you do not have a medium, you do not have the particles at all. So the sound will not be able to propagate. So that is why we say that sound needs a medium. Medium is a must for sound to propagate.
Thank you. Please visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thank you once again.